Okay, now let's go ahead and actually start customizing or creating a custom PLC program. We're going to start off with a simple little uh, a switch will turn on an output. Okay, what I'm going to do is I'm going to show you, start CNC 12 software, and I've got an all-in-one DC here that actually has a limit switch. And so I'm going to show you a couple of nice little tools. First one is the PLC diagnostic menu. At the main screen, if you press Alt and the letter I, this will bring up Centroid's PLC diagnostic menu. You're going to see 4 rows of red and green dots. The top row are your inputs, row directly underneath are your outputs, and then you have your memory bits and stages. Then we also have some word values. Now, as you can see here, there are lots of different inputs and outputs, and if you want to, each page that's on here will typically just show you 80. Now, the first few that are actual discrete inputs, yes, you'll end up seeing 80, but let's say if I wanted to look at the MPG or the probe ones, we saw that they were defined as input 769. We're going to end up hitting the F12 button, and we scroll over to all of them. The one thing that I also want to mention is that, like, for instance, let's say this right here. This is input 420, okay? The 0 on there plus the 42 on top means that it's 420. And then you've got another 0 with a 43 on there. That means that it's 430. And all the inputs in between are 421, 422, 423, 24, and so on. Okay? Rather than having all the numbers listed right on top, constantly just repeating itself, we try to simplify it, but I know that some people I've heard on the phones is people get confused and don't understand, like when I tell them like input 1 and input 11, and they're telling me they don't see an input 11 because they see input 1 being called out multiple times. Okay, but if we keep hitting F12, it'll take you through all the various different memory bits. As you can see, stages are no longer. But you still have a lot of memory bits, outputs, and inputs, and you have all these word values. All right. So if we go out to, oops, I passed it. Okay. Now we're in the 760, and like I said, it started around in 769, 770, and you'll see this white box on here. That will always default to input number 1, or the first one all the way on the right-hand side, or the left-hand side, sorry. You can use your arrow keys to scroll over. And as you can see, as I'm scrolling over, the definition for that, and this is what was defined in the PLC program, matches and follows. But you can see that right in here, it's just a default, but that's because the default INP 732 was because nothing in the PLC program was defined to that particular input. But if I move over to 769, now I see that that is defined as the mechanical probe. And that's because in the PLC program, we defined input 769 as the mechanical probe. So when the compiler compiled everything, it takes all your definitions and it creates it into a .sym file, which is the sim file, and this is what's being shown in your PLC diagnostic menu. So this is pretty much, if you want to verify that something is working, you can highlight or scroll over to it and verify that it's in the correct input or in the correct state. Okay. Now, another beautiful, powerful tool that Centroid has developed with the CNC 11 and CNC 12 systems. Let's go back to the first page. We'll just hit F11 until we're there. Okay. These first few inputs can be inverted. By default, the Centroid control is looking for a normally closed input. Okay. Now, that doesn't necessarily mean that you have to use a normally closed input. You can use a normally open input. All you'd have to do now is you take over or use your arrow keys to scroll over to that particular input. Let's say you're spinning low range. That is a normally open. So it means that whenever the input is open, it actually would be set. And if the input was closed, it means that it's in high range. Well, right now, it would tell me that it's in high range. But if if I didn't have anything wired to it and that input was open, and when it was open it was supposed to be in low range, well, the control is not seeing the state of that input being correct, or it's not seeing that input in the correct state. But in order to invert the logic, all you have to do is hit Control Alt and the letter I, and now that input has inverted. You see that that input changed color from red to green, and if you take a look, if I scroll over, you see that it has this white bar above it. That white bar tells the control that that logic for that input has now been inverted. So rather than looking at a normally closed input for true, it looks at a normally open input. So that means that right now that input is opened, and it's also telling me that it's inverted. So of course, right now, because it's open, it's telling me that it's in low range. Okay, this is going to come true, this is going to definitely be needed for anyone that's going to wire something and is using normally open inputs. Now, one thing that I've seen in the past is that these inputs 1 through 6 on a DC system, they are your limit switches. By default, in every PLC program, these are your axis limits for the first 3 axes. And of course, you've got 2 per axis, a plus and a minus side limit. Now, what I've seen some people do is that if they didn't wire anything up to the control, they go in here and they invert that input. Unfortunately, on the all-in-one DC, Centroid actually has it hardwired into the control, where if that input is not tripped, the all-in-one DC will prevent motion from that axis in that direction. So what ends up happening is that when they invert this input on here, they no longer see the limit trip message that you would see on here. Here, for example, let me just go ahead and put these in the incorrect state. Okay, as you can see, I put the X minus and the X plus limit, and I see a message on here. But if I go ahead and invert this, you see that that message goes away and it's cleared. But even though the Centroid software sees that the message is cleared, the all-in-one DC, that input is still not being tripped, or is still being tripped, which is preventing the all-in-one DC from moving the x-axis in the minus direction. And it definitely makes it a lot harder when support is trying to troubleshoot something, because if you invert inputs 1 through 6, and then all of a sudden you call up and saying that the axis isn't moving, Centroid support is probably going to start going through the typical standard things. All right, do you have motor voltage? Do you have power going to the drive? Are you getting any kind of faults? And how I found this out was that I actually team viewered into someone's system, and when I brought up the PLC diagnostic, I saw that they inverted all their inputs. So if you do have an all-in-one DC input, you cannot invert inputs 1 through 6. They have to be normally closed logic. Now, that doesn't mean that you have to use them. I've had a couple of people that have their limits aren't normally closed, and they weren't willing to go out and buy normally closed switches. They wanted to reuse what was on there. That's perfectly fine. What they have to do, though, is leave inputs 1 through 6 as is, and then defeat them on the all-in-one DC, then wire in their inputs to any of the other free input, and then in the motor configuration menu, just set that particular input to whatever input it was wired to. Okay, but long story short, all-in-one DC system, inputs 1 through 6 cannot and should not ever be inverted. Okay. All right. So, as you can see here, I have a little limit switch, and I'm just flipping the switches, and you see my inputs changing state as I flip them. Okay. Now, as you can also see that once I flipped various different ones, I started getting messages. For example, when I flipped number 9, I got this lube fault. And if I take a look, That's because number 9 is defined as my loop OK signal. And of course, when I flip number 10, my spindle inverter OK, I got this spindle fault. Okay. Once the software gets into a fault state, it will always remain in a fault state. And at that point, I can't do anything. For example, let's say I go ahead, all right, the spindle is already in manual mode, and if I go and try to turn the spindle on, I don't see my output ever coming on. And if I take a look, if I scroll over, my spindle enable output is output 7. That output is not turning on. And that's because the control is in a fault state. So in order to clear that fault state, we have to cycle the e-stop. And the e-stop is almost always defined by input number 11 on the Centroid stop. So if I flip my e-stop, you can see that a message will pop up saying emergency stop detected and message cleared. So now if I release e-stop, emergency stop is released, and you'll also see that output 1 went green. And output 1 on all of our Centroid's PLC programs is defined as no fault out. And that means that if the CNC software doesn't see any faults, it'll actually turn, output 1, it'll turn that on. Now if I wanted to go in and turn my spindle on, now you see my spindle went on. I actually saw a little speed being up here, but output 7 is now green, which tells me that the spindle turned on. Okay. All right. So now when we're going to create a custom PLC program, I'm going to make sure that I don't end up putting it onto anything that's not being used, because chances are there's probably logic in the PLC program that's looking for that, and I don't want to override it. Okay. So what we're going to end up doing now is we're going to close this. So now you saw that software is coming on here, PLC detective. Oh, another thing too. To turn the PLC detective on, remember we hit Alt and the letter I. To turn it off, we do the same thing, Alt and the letter I. So Alt and the letter I turns it on, Alt and the letter I turns it off. Actually, another thing that I'll end up talking about, remember how we went over and said that you can invert inputs very easily just by hitting Control-Alt-I? Okay. I just inverted that input again. Once again, you saw that now it doesn't, that line above it went away. That means that that input is no longer inverted, and so now it's using normally closed logic instead of normally open logic. Now, in addition to inverting inputs, we also have the ability to force outputs. Okay. As you saw before, when I clicked on spindle enable, I turned out output 7 on. All right. And I just clicked on this and turned it off. But if I wanted to, I can force an output just by taking that white box, scrolling over to that particular output, and now I'm going to hit Control, Alt, and F for forcing. As you can see, that input or that circle changed from red to green, and there's a white line or below that particular output. That white line tells the controller that that output has been in a forced state. Okay, when forcing, you've got 3 states to go to. The first time you hit Control-Alt-F, it forces the output on. Second time you do Control-Alt-F, it forces the output off. Third time you do it, it puts the output back into the normal state. Okay, so as you can see here, it's forced on. I'm going to hit Control-Alt-F, and now it's forced off. All right, there's still that white line underneath it, which means it's in a forced state. Hit Control-Alt-F again, and now it's back to the normal state. Okay. This is also going to be very critical because remember, you go force on, force off, and then back to the original state. I have seen some people before that have called and said that, hey, this output isn't working, and going through in the logic, everything is working correct, so the logic should be turning the thing on. But the only way to figure it out, that the reason why it's not turning on, would be in this PLC diagnostic. I have found that what happened is that they probably forced the thing on for testing, making sure that everything was wired correctly, or making sure that that output fully functioned on the machine before the PLC program ever handled it. And then they hit Control-Alt-F, and then they forced it off. But all they did was they saw that it went from green to red, and they assume that that was done. Well, then when they try to actually have the PLC control it, it wouldn't. Okay, so for example, let's say right now I turn the spindle on, and I can turn it off using the buttons. All right. Okay, I'm gonna force it on. All right, now that I'm forced on, you see I can't turn it off because now the PLC program can't control it. All right, now I'm gonna force it off. All right, now when I'm trying to turn it on, it won't turn on because it's in the forced off state. So I have to hit Control-Alt-F again to get it back into the normal state. And like I was saying, as long as you don't see that white line underneath the output, it's back to where it's in its normal state, which means that the PLC program will turn that thing on and off. And now I can turn it on and off via the PLC program. Okay? All right. So now let's go ahead and let's get back to creating that simple little switch that will turn on an output. All right. So we're going to go back into our source code. Now the other thing that I just did, I turned off the Centroid software. It's always wise that whenever you're trying to create a custom PLC program, that your software is not running in the background. Okay? Because you're going to essentially modify and update the source code. Okay, so first thing that I'm going to end up doing is I'm going to go here in the file name, and as always, because I'm making some kind of modification, I am going to rename this. All right, so I'm just going to rename it and do simple test. Okay, so that means that because I renamed this file, now whenever I go to compile it, I'll have the new compiled program loaded onto the control. But let's say that there's something that's still not correct and I'm still trying to troubleshoot it. Well, if the operator, the user, is still using the machine, because I didn't overwrite the old one, I can still go back, compile the original file, and get that machine back in its operational form. Okay? So, basically go on here, put the file name. Now, like I said, if I wanted to, can go on here and make a little modification saying, all right, what's today's date? Oops, today's April 15. Adding okay. Now once again, I'm going to put a semicolon here because if not, then this would have been a valid line, and when I went to try to compile it, it would not compile. It would fault out. Okay, so I'm going to make that into a comment, and I'm just adding spaces to make it nice and clean and easily format. All right. Now, because I'm going to add this, all I'm going to do is take an input and just flip that input switch. All right, so we're going to go into my input definitions. All right, and typically I would look for something that actually has a spare. All right, now as we can see, we have all these inputs that are spared, but in my test station, I don't have a PLC add 1616 on there. But I do see that there is a spare on here, so I'm going to go ahead and use input 16 as far as my test. All right, so I'm going to define that. We'll call this switch 16. Okay, so now I'm defining switch 16, and that means that in the logic in my PLC program, it's going to have it associated with switch 16. And all I'm going to do is I'm going to turn an output on based on the state of that input, switch 16. So now I need to go ahead and define an output. All right, and as we can see here, all my outputs are actually being taken care of. They're being used and utilized for something. So what I'm going to do now is I'm going to use or rename one of those outputs. Let's say work light out. So I'm going to use that output as my little tester. But because this is defined, there's already logic in the PLC program that's turning that work light out output on. All right. I want to get rid of it because now I want to use my own new custom logic. So what I'm going to do is hit find and find all the locations that I'm doing or working with that definition, the work light out. I'll hit enter, and lo and behold, here comes my work light out section. Now if I wanted to, I can hit find next to see if there's any other logic in there, and you can see there's only two locations in there. One where it's being defined, and the other one that actually has the logic associated with it. So what I'm going to end up doing is I can either A, because I'm no longer going to have this work light out, I can go ahead and delete all this, or just I can comment this thing out. So in case I wanted to use it again in the future, I have that logic that's in there. So I'm just going to go ahead and hit add a comment to these lines. Now, one of the beautiful things that you just saw me do right there, I commented out this entire section. Notepad++ actually allows you that if you hit, let's say you click on that thing, on that little right in front of that if you hit Alt key and hold it down and now you move it up, you actually get to select a column rather than the typical if you do this, because it selects everything up. So if you hit the Alt key, it's a little shortcut that I love from Notepad++, because you can comment an entire section out very quickly rather than doing it adding a semicolon in front of every single line. Yes, this was a lot easier because it was only 3 lines, but let's say I wanted to comment out this entire section here. This is a lot bigger. And you can see, like if you want to comment an entire stage out, there's a lot of logic or a lot of constant going in there, adding a semicolon, moving down to the next line. So there's a lot. To make things simpler, you just hit the Alt key and then left click on your arrow, and that allows you to move it up, and then you can just easily add a semicolon. So right now, by adding a semicolon, we commented all this section out, which this is directly related to that work light out. So now there's nothing in here that it's going to be turning on work light out. So we're going to go back to the beginning where we define it, and now let's define it as something else. If we wanted to, we could keep the same name, but let's make it OT6. Oops. Little keyboard shortcut keys here. Sorry about that. So we call it OT6. All right. So now we define an input as switch 16, and we define an output as OT6. All right. So that means that the logic that's in the PLC program has to match what's being defined in here. So I can't put in there in the logic saying OUT-PUT6. I have to put it as whatever I define. So it's got to be OT6. So now let's go and actually define it. All right. I'm sorry, not define it, add the logic to it. Now, of course, when we add the logic, like I said in my previous thing, typically you'd always put it in the main stage. So let's go ahead and search for that main stage. Okay. And here we go. Here's the main stage. Now we just go ahead and add that logic. Pretty much you can add the logic anywhere on here that you want to. What I'd probably recommend is, as you can see on here, it's got this little section that says Pro Protection While Jogging. I probably wouldn't put it in that section. I would probably make your own little section. It can be at the beginning, the end. As long as it's in the main stage, it'll be perfectly fine. What I'm going to do is put it right here, right after the work light output. So like that, if I search in the future for work light out, it automatically take me right to that section of the PLC program. All right. So first thing I'm going to do is I like to put a comment and say simple input test. Okay. This right here, this first comment just tells me that this section is going to be part of my customized thing. Now, if I was going to create a stage, sure, that's fine. You can go ahead and create a new stage as well. All right. So I'm putting in here, this is going to be in the section for this entire simple test. Then I also like to put a comment that says what the line of logic is going to do. And it'll be something like turn on OT6 based on state of switch 16. Okay, so oops, as you can see that I somehow put an enter there by accident because I wanted to make sure that this was a comment, because if it was on this line and I try to compile it, that would fail on me. All right. So let's go ahead and now we actually add the line of logic. So we put in the if. Now what's the condition? The condition is this switch 16. Oops. So if that condition is true, then I'm going to set OT6. Okay. Now I'm also going to have, because now that I turn that output on, I need something to turn it off, because if I don't turn anything off, after that output will remain on. If I exit out of the software or get into an e-stop state or something, that output will still remain on. So I have to have something that tells it to turn off. So the next line of logic that will say, if not that input, then reset OT6. So this line of logic will turn, if this condition is true, it will, which means that that input is closed, it will turn this OT6, which we've defined it as an output, it will turn on out. And then if switch 6 is open, which switch 6 at that point won't be true, but the inverse of it will be true, it will then reset OT6. Okay? So now let's go ahead. Let's save this. Of course, going to save it as. All right. Save it as the same file name that we have here. Simple test. All right. Now, as I said before, I always like to leave the extension .src because it makes it so much simpler. But I don't have to. The only thing that you have to make sure, though, if you're using Notepad++, you might need to make sure that this thing is set to all files. Because if it's set to .txt, it's going to put that file, it'll be a .src.txt. All right. The other thing, too, is you always want to make sure that you save your source code files into the main either CNCM or CNCT directory. Of course, CNCM for mill, CNCT for lathe. All right. So go ahead and save it. Excellent. So now that that file has been saved, now I want to go ahead and compile it. Now to compile it, all you have to do is press F6, and it brings up this command. Hit OK, and it brings up your command piler. And lo and behold, let's minimize this. Okay. And lo and behold, we got this compilation successful. Okay. All we do now is hit any key. Boom, this is now done and compiled. Right. But let's say for argument, let's go ahead and try, like I was suggesting before, where if it wasn't an actual line, actually not being able to compile. So what I'm going to do is let me just search for OT6. Oops. Okay. Looks like. All right, so let's say this was not a comment. This was now, say I had it like that, okay? Which means that this is now no longer a comment. And as you can see, with the setup that we just ended up doing, with the compiler that we ended up loading, all your comments are highlighted in green. Anything as far as your PLC logic is concerned is highlighted in blue. For example, like the equal to, the then, the if, the logic ands, the sets and resets, it makes it so much easier, and it'll be perfect, especially when you're trying to troubleshoot. All right. So now we've gone ahead and we've made this, and we put it on here, so this is no longer a comment. All right. We go ahead, save it, and now try to compile it again, and we see, whoa, okay, it comes on here and it says there's a warning. Undefined label, turn, because it doesn't know what turn is. And that's because the turn, exit out of this, really, there's no definition. It doesn't know. There's no if, there's no then. The compiler has no idea what to do with this line. So we bring it back to the normal state, we correct it, save it, and recompile. Okay, compiled successfully. Now let's go ahead and test this out. All right. Now, after you make any kind of changes, you always want to make sure that you repower your hardware, because even though you're starting the software, you're not repowering your hardware. If you don't, you will end up seeing a message, which I'm going to show you right now. I'm going to restart the software without restarting the hardware. Okay. When the software restarts, it's going to tell you, hey, there's an issue. And see, there's a warning. It's saying the PLC program, it changed, and it requires you, or it wanted you, to restart. Sometimes you can get away with it, but sometimes you can't, and especially if you make changes in the initial stage, whatever changes you made, at this point, now won't take into effect. So, for good practices, it's always good and wise to then just always repower the system. Now, if you wanted to, I could go ahead and hit F1 continue. Because my change was just a simple change on there, it really wouldn't affect it that much. But to be safe, on the safe side, just anytime you make any changes, always make sure because you have to, of course, restart the software, make sure that you restart the hardware as well. All right. So now we're going on here, and we can see that output 6 has now been defined to OT6. All right. And we can also see that input 16 has been defined to switch 16. So now what I'm going to do is I am going to flip a switch, input 16, and you can see that input 16 is turning on and off dependent on the state of that input 16, which is exactly what we wanted. And I don't know if you can hear it on, but you can hear the relay clicking on that all-in-one DC. All right. So now, because you can have that, we've now made our own simple PLC program. But now we're going to do it. Let's make it a little bit more complicated. All right. So now I'm going to shut this off. All right. Go back on here. So now, here's the logic, and like you said, we have two lines of code, one that's setting it and one that's resetting it. Now, if you want, I'm going to comment this section out. Okay. I'm going to save this, and I'm going to recompile. Now, you might be asking yourself, well, hey, it won't compile because there's nothing that's actually doing or setting anything with the OT6 because I have it defined. Well, just because it's defined, if there isn't any logic in there, it'll still compile. The only time it will gawk at you or fail on you is if you have something set on here, but then that is not being defined in your statements. So let's go ahead and I'll show you really quickly. Save this. Let's go ahead and compile. And see, lo and behold, it compiled. Okay. So now I'm just going to show you that now it compiled, didn't have any errors. I'm going to start the software again. Oops, I forgot to repower this thing, but not a problem. I'll do it next time. Just hit F1 continue. Bring up the PLC diagnostic. Remember, oops, there's a reset. Okay. That reset was because the system was in a fault because the software was restarted without the hardware being restarted. So I go Alt-I, and now if I flip input 16, you see that the input changes state, but nothing is turning on my outputs because there is no logic behind that. Okay? So now, let's go back to the source code. All right, let's just, for argument's sake, say that this one's on, and I'm going to call it OT6A. All right. Now remember, I never defined anything as OT6A, but I did define it as OT6. So now if I try to save it and then compile it, it's going to fault out because it says, hey, I don't know what this OT6A is because it's never been defined. And so that's why whatever you put in your definitions, whatever's in your logic has to match what was defined in your definitions. All right. So now let's go ahead and I'm going to show you how these two lines will also work. Let me just go ahead, copy this. If switch 16, then OT6. Okay. So this one line is going to end up doing the same thing that these two lines were doing. So this line means that if switch 16, this condition, switch 16 is true, then OT6 will be set. If this condition is false, then OT6 will be false. All right, so now let's go ahead and save it. And because we're going to save it, we're going to do simple coil test. Let's save it as a different name. Simple coil test. Remember, we're always saving into the main CNC directory, which in our case is CNCM. Save it, compile it. Lo and behold, everything compiled successfully. We didn't have any faults. Let's go ahead and actually run it. But this time, before I actually start the software, I am going to power off the hardware. Okay, it's up and ready. Let me go ahead and start the software. Oops, I guess it wasn't ready. Start it now. Yeah, that message essentially meant that I was trying to start the software, but the hardware was not yet ready, so it couldn't communicate with the software, so it timed the thing out. So I just needed to wait a little longer to make sure that the hardware was up and ready before I started the software. And as you can see, when I started the software, I no longer got that message that said there was something different in the PLC program and that I needed to either A, press F1 to continue, or B, press F10 to power off the system and reboot the entire system. All right, so now let's bring up the PLC diagnostic menu. Once again, hitting Alt and the letter I. Now we're going to go to OT6. We're going ahead and flip that switch. And you can see now that that output is turning on based on the state of that input. Okay. Now, if I wanted to, because as of right now, this is my input being in an open state, I'm flipping it into a closed state. All right. And when I flip it into a closed state, input 16 is green. All right. But let's say I'm going to flip it open, and that input is now and normally open rather than normally closed. So I'm going to go in here and invert that state. All right. You see that turned green? There's a white line that's telling me that the logic is now normally inverted, or I'm sorry, normally open, which means that it has been inverted. And of course, I didn't flip the switch, so the input is in fact in an open state, and you can see that my output is still on, because my output is just looking to make sure that this condition is true. And as long as this input is green, then this output will turn on. And so now when I close the switch, even though it's closed, my output turned off, where before my output would turn on when it's closed. Now my output is turning on when that input is open. Okay. And now we have essentially created our own first simple custom PLC program. So now we can turn on an output based on the state of that input.